We're going to continue building on our use of derivatives to help us graph functions. And the next piece that we're going to learn is the first derivative test. So the first derivative test is going to determine if critical points are mins or maxes or neither without using our graph. So we're still going to be finding our critical points, but this time we're not going to be actually finding values of our critical points. We're just going to be using our first derivative to help us decide, is that critical point a minimum or a maximum? In order to do this, we're going to be looking at what's happening around the critical point. So let's say I have a critical point at a certain x value. Okay, so I know that when x is this value, there's a critical point, which means it's either a relative min or a relative max. Okay, somewhere on this x value. Well, in order to determine if it's a min or a max, I would need to know if just to the left, if my slope just to the left of my critical point was increasing. If it's increasing and then it's decreasing on the right, that would tell me it's a maximum. If it's doing the opposite, so if on the left it's decreasing and then on the right it's increasing, that would tell me it's a minimum. So what I'm going to do is I'm going to find these critical points and I'm going to plug in values that are just left and just right of them to determine if it's increasing and then becoming decreasing or decreasing and then becoming increasing. And that'll tell me if it's a minimum or a maximum. So let's do this first example here. So I'm going to take the derivative of this. I want to know what my derivative function is. This is going to require the chain rule in this particular function. So I'm going to drop the 2/3, leave the inside part alone, subtract 1 from the power, which makes it negative 1/3, and then multiply this by the derivative of the inside part, which would be 2x. So if I simplify this a little bit, 2 here and 2 here, okay, 2x times 2 is 4x, and that's on the top. I've got a 3 on the bottom. This is going to come down to the bottom because it's a negative power, and I'm going to turn it into the third root here. Okay, so I need to know the critical points, so I'm going to set this equal to 0, and that'll tell me critical points. I also need to know when it's undefined, so I'm going to set the bottom equal to 0. Because if the bottom is 0, that's going to make it undefined. So I want to know when the denominator is 0 also. Because that'll tell me which values make this undefined. So if I'm solving this, I'd multiply the denominator on both sides, and that's basically going to get rid of it. And I'd have 4x equals 0. So x equals 0 is one critical point. Here I can divide the 3 over, and I can cube both sides, which would leave me with this. If I solve this, I get x squared equals 4, so x is plus or minus 2. These are my 2 other critical points. So here's all my critical points. I'm just going to plug in points that are around them to determine if each one is a min or a max. So we'll start with 0. If I put in a point that's just left of x, of 0, so like negative 1. If I put negative 1 in here, the top is going to be negative. Okay, it really doesn't matter what it is, because all I'm looking for is positive or negative. Because if my slope, this is my slope function, if I put a value in and it turns out to be negative, that tells me that my function is decreasing on that side. If it's positive, it's increasing on that side. So the top becomes negative. If I put a negative 1 in here, I'm going to get negative 1 squared is 1, minus 4 is negative 3. The cube root of negative 3 is some negative number, times 3 is some other negative number, so I get negative on the bottom also. Negative over negative is positive. So that means when x is 0, on the left, because I plugged in the number that's left, negative 1, I'm getting a positive slope, so it's increasing. So I'm thinking it's going to be a relative max, but I can't be totally sure yet. I still need to check the right side because we're actually going to get into these other points that can allow critical points to be non-relative mins or maxes. So I need to test both. Okay, so I'm going to test to the right. I'm going to put in 1. If I put in a 1, I would have positive number on the top. So this is for -1. This is for 1. I'd have positive on the top. 1 squared is 1, minus 4 is 3, the cube, or -3. The cube root of a negative is negative, times a positive is still negative, so I have positive over negative, which is negative. So this is decreasing, as I'm getting a negative derivative, which is a negative slope. You can think of it as a slope. It wouldn't really be a slope because it's not a linear, but it's decreasing. Okay, so that means that 0 is a relative max. So now let's check -2. So I'm going to I already put in -1, so I can use that. That'd be my right side now. So my right side is increasing. So my right side is increasing. Oops, that's decreasing. The right side is increasing. My left side, if I put in -3, I'd have negative on top. I'd have -3 squared, which is 9. 9 minus 4 is 5, which is positive. The cube root is going to be positive, times a positive is going to be positive. So you have negative over positive, which is negative, which means this is decreasing, which -2 would then be a relative min. Let's check 2, our last critical point. I've already done 1, which is left, so I can use the same answer here to know that the left side is decreasing. If I put in 3, I'm going to get a positive on top. 9 minus 4 is 5. Cube root of a positive is positive, times a positive is positive. So I have positive over positive, which means it's increasing on the right side of 2. So this is also going to be a relative min. Which should make sense because 0 is in between these two. So it's kind of, okay, I've got a min somewhere at -2, then a max at 0, and then another min at 2. So I'll do a couple more examples. Okay, so I'm going to start the same way. I need to find my critical points. So I'm going to find the first derivative. This requires the quotient rule. So I'm going to take bottom times the derivative of the top, which would be 4x cubed, minus the top, oops, x to the 4th, plus 1 times derivative of the bottom, which is 2x, divided by the bottom squared, which would be x to the 4th. We can simplify a little bit here. So I have 4x to the 5th minus 2x to the 5th minus 2x over x to the 4th. Subtract these to get 2x to the 5th minus 2x over x to the 4th. One of these x's will cancel from everything. So I'm going to have 2x to the 4th minus 2 over x cubed. And then I can factor this. Actually, let's leave it just like this. So this is my first derivative simplified. I need to find all the critical points. So I need to know when it's undefined, which is when the denominator is 0, and that's only going to happen when x is 0. So one critical point is 0. I need to know when it equals 0. So I need to know when this top equals 0. Well, the top, I can divide by 2. This is factorable. This is a difference of squares. So this is going to be x squared plus 1, x squared minus 1. Okay, this factors again into x plus 1, x minus 1. So if I set this equal to 0, I'm going to get plus or minus I. Okay, I'm going to imaginary, so those aren't zeros. here I'm going to get -1, so that's another critical point, and +1 is my last critical point. I'm going to put these in order, actually. So these are my critical points. Now I need to determine if they're relative mins or relative maxes. So -1, okay, I'm going to put in a number that's left of -1 to see if my slope is increasing or decreasing. Okay, I'm putting it into my first derivative, which I'll rewrite over here. So numbers left of this, okay, are going to be negative. So I could pick a specific one like -2, or I could just say for a negative number, what's it going to be? So if I put a negative in here, negative to the fourth is positive, times 2 is positive. Actually, I better pick a specific one since I'm subtracting. So let's put in -2. Negative 2 to the fourth is 16, times 2 is 32. Minus 2 is going to be 30, which is positive. Okay, so I'm getting a positive on top. -1 cubed is a -1, so I'm getting positive over negative. So this is a negative slope on the left, which means it's got a negative slope. To think of it that way, it's decreasing. If I try a number to the right, okay, when I go right, I don't want to go up to 0 because I know that's another critical point. So I need a number that's kind of in between there. So if we do -1/2. -1/2 to the fourth is going to be some positive decimal. Okay, it's going to be positive 1/16. Times 2 is 1/8. Minus 2 is going to be a negative. So I'm going to have negative on top. Negative cubed is a negative, so I have negative over negative. So this is positive on the right, which means it's increasing. So -1 is a relative minimum. Let's try 0. Okay, 0. I'm going to try a number to the left. I just tried -1/2, which got me positive, so it's increasing. If I try something that's between 0 and 1, it's going to be like positive 1/2. So 1/2 to the fourth is 1/16, times 2 is 1/8, minus 2 is negative over 1/2 cubed, which is positive. Negative over positive is negative, so it's decreasing. 0 is a relative maximum. Okay, last one to try is 1. I just tried 1/2 and found out it was decreasing. If I try like 2, which is to the right, 2 to the fourth is 16, times 2 is 32, minus 2 is 30, which is positive, over 2 cubed, which is also positive. This is positive. So this is another relative minimum. Okay, last one here. So why don't you guys hit pause, try this one, then come back and see if your answer matches mine. All right, so I need the first derivative again. So quotient rule, bottom times derivative of the top, which is 1, minus top times derivative of the bottom over the bottom squared. Distribute on the top. So we have -2x squared minus 6x over x to the fourth. Simplify the top here, so we have -x squared minus 6x over x to the fourth. I can cancel an x out, so you get -x minus 6 over x cubed. I need to know when the denominator is 0, so that will tell me where it's undefined. This is going to happen when x is 0. And you know when the top equals 0, so you know when -x minus 6 equals 0. That's going to happen when x is -6. So these are my two critical points. Okay, so I'm going to test -6. I'm going to pick a number that's left of it, like -7. -7 is positive 7. Minus 6 is positive 1. Negative 7 cubed is going to be some negative number. So I have positive over negative, which is negative. So this is decreasing. To the right, I'll try something that's not up to 0 yet, but just something between negative 6 and 0, like negative 5. Negative 5 is positive 5. Minus 6 is negative 1. So I've got negative on top. Negative 5 cubed is a negative number, so I've got negative over negative, which is positive, so it's increasing on the right. So this is a relative minimum. 0. Okay, I just tried negative 5, which is left of this, and I got a positive slope. Now if I put in 1, I have negative 1 minus 6, which is negative 7, over 1 cubed, which is 1. Negative over positive is negative slope. So this is a relative max. Okay, and that's how the first derivative test works.